Pain, itching, and burning are uncomfortable side effects of bacterial vaginosis and trichomoniasis. Left untreated, however, and these conditions can increase a woman's chance of contracting other STDs, including HIV, chlamydia, and gonorrhea. Bacterial vaginosis and trichomoniasis significantly increase a woman's risk of pelvic inflammatory disease, or PID, which can make it difficult or impossible to have children. These diseases can be diagnosed by collecting menstrual samples from women, then analyzing them in a lab setting. Some medical clinics already do this. For example, Dr. Strum from the University of Natal in Durban, South Africa. Strum would have patients insert a tampon for 15 to 30 minutes, take the tampon to the clinic, and then use polymerase chain reaction to diagnose the disease. But if you're a person who wants to do simple diagnoses without resorting to a visit to the doctor, your options become limited. A few biotechnology companies currently claim to be developing smart tampons that use the biological samples from the tampon after its use in order to gauge reproductive health or discover early signs of disease. But once again, the consumer needs to send their tampon to the company, which effectively renders what was once a personal, do-it-yourself product into a professional service. Our goal is to create a tampon that will indicate whether the user may be at risk for having an infection. The tampon will detect the pH of the user's vagina and determine whether that pH is at a normal range. We found that pH can be used as an indicator for the onset of disease. For example, a healthy vaginal pH ranges from 3.8 to 4.5, but if one suffers from vaginosis, they'll have a pH above 4.5, and a person with trichomoniasis will have a pH above 5.4. There are vaginal pH tests available on the market, but these existing models are unfamiliar and uncomfortable to use. They require women to insert strips or swabs into their vagina, placing litmus tests against the wall. Our product, Sanitamp Diagnostics, is similar to a normal tampon, although it is smaller in size. It is designed to be used during non-menstrual periods. It comes with a tampon container, which the pH indicator is embedded on the container. The user operates the product similar to a normal tampon, insert into the vagina, but remove it after 1 minute. The tampon is then put into the container, which the pH indicator will detect the pH of the tampon and display the result. The system can be discarded safely. Similar products and services do not offer the same convenience and simplicity that Sanitamp Diagnostic offers. All the consumer needs to do is use a tampon as normal. Then, once done, place the tampon in the included container and wait for the indicator to display a color change. We chose our indicators to be sensitive to the pH range of 3.8 to 6.0 and to be visually more distinguishable than competing products by offering a range of highly contrasting colors. Overall, this process is quick, easy, informational, and non-invasive. Each Sanitamp Diagnostics is meant to be used once before being disposed of. However, our indicators are also compatible with third-party tampons, allowing the consumer to use the tampon that she is most comfortable with. Once used, women that are possibly at risk should immediately consult with their physician. Currently, we are still in the development phase, hoping to finalize the design of our product soon. Due to the lockdowns as a result of COVID-19, we've been experiencing some developmental delays, but hopefully we can fast track our product development once normalcy resumes. We hope that our product, Sanitamp Diagnostics, delivers an accessible, privacy-courteous method of keeping the global female population healthy and comfortable while reducing unnecessary lab visits and incidents of vaginal health crises. Our small, easy-to-learn, and easy-to-use tampon proposes value over current methods of over-the-counter, at-home vaginal testing methods. With Sanitamp, women will be able to self-test accurately and safely, an invaluable service in deciding whether physician consultation is necessary for their own health. We would like to thank Dr. Donahue for his guidance in product design and for his contributions to the development of Sanitamp Diagnostics, and to Carmen Cardizano for helping procure supplies and ensuring our safety, and also to the JHU Department of Chemical and Biomolecular Engineering.